Okay, welcome everyone to this continuation of what is machine learning in mathematics, right? Keep it in mind, machine learning in mathematics, not the other way around. So you're wrong here if you want to learn about the mathematics of machine learning. And this time I would like to tell you about one of my favorite topics in mathematics, and it's now part of computer science, as we will see. Automated proofs. So maybe it was already part of computer science when it started, but kind of math and computer science, it's the same anyway, all the same. So AI and automated proofs. So the whole idea, let me just jump to the first slide. The whole idea is actually pretty old, and it's the same mantra all over again. Eventually AI will replace all of us. We all know that, however, right? But how long it will take, yeah, that's not so clear. But anyway, as a mathematician, you should work on yourself, or you should work to replace yourself. Yeah. So kind of no humans, please. In particular, no mathematicians, please. The biggest bullshit job ever. So recently, I was talking with someone. And well, then eventually, if someone new, you get started to chat, and eventually it comes up. So what are you doing for a living? And I said I'm a mathematician, and they didn't know what that mean. Like literally no idea what that is. Usually I just get, so you teach mathematics, which is not true. I'm not teaching mathematics, but anyway, so it's kind of a very strange job. Nobody knows what that is anyway. Completely useless. So let's try to work all together to get rid of all mathematicians. Including myself, in particular including myself. And this idea is pretty old, actually. So I think this started essentially when the first computers after World War II became like publicly available. So the World War II, they already had computers, but they weren't really using it for, let's say, non-military purposes. Kind of makes sense if you're in a big war. But anyway, afterwards, like in the 1950s, the first universities did have had those computers, and they were just these really large things, this vacuum tube type computers. And immediately as that started, they started thinking about, well, mathematics, maybe we just formalize everything, right? So this idea of formalizing everything, just writing down very carefully a formal proof, is like very old, and doing it on a computer is like in the 1950s. Essentially, a computer should be very good at that, huh? And let's just make the assumption, which is a kind of a completely ridiculous assumption, very far from being true, but for this video, just do it. Let's say mathematics is nothing else than proving theorems. Then kind of having an automated way to prove theorems would get rid of all mathematicians. It would be excellent. As I just said, nobody knows what a mathematician is anyway, so why not get rid of them anyway? And this goes under the slogan of automated theorem proving. I originally wanted to write automated proof writing, yeah. Automated theorem proving is what it's called, and I wanted to write automated proof writing, but this is slightly different. Automated proof writing, as I wanted it originally, it's really just saying that a theorem made by a human and a computer writes the proof. Automated theorem proving is not necessarily restricted to the theorem as already given. So the computer can also discover the theorem itself. So it's kind of a really broad spectrum, right? The computer just does everything. There's really no human involved at all. The state of the arts is pretty bad. So they essentially only do like very basic stuff. So here's some conference poster from the 1960s, and they were kind of having a conference of automated or formalizing certain types of set theory. So that's usually what people do, some basic mathematics, right? So we're like very far away from kind of having automated proofs for the more modern math theorems. And it's also very different from formalizing proofs on a machine, which is in a pretty good state actually. So all of the French undergrad curriculum, like linear algebra or whatever, has all been computer verified. But it's like works very different. There's a human that takes a human-made proof and just puts it into computer form, and the computer checks whether everything is correct. Here we are talking about automated theorem proving, yeah? And can't make this point clear enough, so let me just sound like a broken record and say it again. No humans. So really nothing. There's no human that types the proof or something. No. Just the computer does everything. And the state of the art of this part of, well, replacing everyone by AI is actually not all that great. Yeah, and we really need to work on this, and people are doing this with a new approach. In the modern era, like in the last 10 years, AI was booming, right? So the new approach will be to use some form of AI. Before that was essentially just piecing together random sentences until there's something that counts as a proof. And now you want to do that in a little bit in a smarter way. And the motivation they took is from Go. So computers playing chess, it's kind of very old. When I was younger, there was already a computer playing chess, and I had no chance to beat it. Go took a little bit longer, and Go really was kind of taken over by computers in the AI area. In the AI era. So like starting 10 years ago or something, we'll do that. And essentially, this was the starting point of thinking about, okay, Go, a lot of people think of Go as a formal system, and formal statements is very crucial for automated theorem proving, are the formal system. Go is like this miniature formal system, so what should be good at Go should also be somewhat good at theorem proving. Yeah. So the classical Go was run on a convolutional neural network, but the modern versions are more in, the transformer. We'll go to that in a second. But here's one of them. So AlphaGo, as it says, it's Go, yeah, and it's from Google DeepMind from October 2015, and kind of the state of the art. You can scroll down here on the Wikipedia page. It's kind of fun. So they had several Go programs, roughly starting from 2015. They became really good. So they played good against real players, and eventually they became so good that here the last one, you only compare them to themselves. It's kind of very annoying for professional Go players. So the modern versions of Go playing computer programs are just really, really, really good, and most of them are AlphaGo, for example, is based on some version of a GPT, in this case a convolutional neural network. Yeah, so that was kind of the starting point. People just realized that Go is very similar to theorem proving, kind of a fun thing. So chess, very different. Go, like more, not very different. You can also do chess with those types of neural networks, but chess was kind of understood way before, and Go was kind of very complicated for a long time. But anyway, the architecture that can do Go, people conjectured that to be, maybe it actually can do the automated theorem proving as well. And that's what they did a little bit later, when already the transformers were out. So in 2015, we didn't have any really good transformers, because there was this breakthrough paper, Attention is All You Need, which introduces this attention network, which might have been, we'll see. But maybe it actually is or was the most important paper of this century, essentially introducing the GPTs, the large language models, everything underlying ChatGPT and friends. And this is also what people use then in automated theorem proving. Essentially, you want to have some form of reasoning here. Whether you really call that reasoning, a bit questionable, but kind of a GPT has some form of reasoning, right? So kind of you want to think that maybe that's the thing that can do this type of mathematics in the best way. And the paper I used, I just pulled it up anyway, is this one. It's from 2020, so they already had transformers and whatever. This time from OpenAI, not DeepMind, the other company, OpenAI. And they introduced this model that they called GPTF, and they ran it in a certain language they call MetaMath, and they were pretty successful. So somewhere at the end, they have a discussion. The performance, so A is the number of repeats they allowed. So essentially, they came up with a performance of 56%, meaning that they were able to, or the program was able to automated fill in 56% of the presented proofs, which is very, very, very good, actually. So 56%, that's way more than I could fill in, way, way more. So I feel like the Go players already here, the machine is way better than me. And yeah, so the quote that I found in the paper, I think this is really good. This work is motivated, so exactly the paper I showed you, by the possibility that a major limitation of automated theorem provers compared to humans, the generation of original mathematical terms, might be addressable via large language models. Right? This is kind of a new idea that came up about 5 years ago, and it performs really well compared to what was done before, which was not all that great in the automated theorem proving community. The problem is most of the proofs are still reasonably boring. I have one here. They give several other examples if you just scroll through. So this is, by the way, how a formal proof will look like. It's kind of a lot of bullshit. So they did mostly very simple things like addition, division, modulo, exponentiation, and you can write down different formulas, or a little bit in some easy ring theory, something like an equation of that form, right? We're still very far away of doing kind of the honest new math, but it's pretty good, and it's pretty good first step, I think. It's kind of a really new idea and seems to work reasonably well with kind of the generation of GPTs we have at the moment. So ChatGPT in principle should be able to cook up kind of real proofs that are accepted by the math community. And another upshot they came up, actually maybe for now the main upshot of the paper I just presented, they actually found several essentially simplifications of proofs. So they made known theorems proofs shorter, which is very good. It's kind of efficient, right? So here, my favorite picture, and a very efficient proof of the sum of the odd numbers will be a square. Yeah? 1 is a square. 1 plus 3 is a square. 1 plus 3 plus 5 is a square. And you literally just see that. So very efficient proof. And the main upshot is that they really found these new shorter proofs of known things. Admittedly, everything was known, but shorter proofs. And they were actually accepted by the math community and added to the corresponding database, which I think is pretty impressive. Anyway, I hope you enjoyed this video, and I also hope to see you next time.